Now we're ready for solving quadratic equations. So you've seen this before in college algebra, but we're going to see it again and make sure we're great at it. There's four main methods that we use. One is by taking the square root. The next is factoring, completing the square, and quadratic formula. And then at the end of this worksheet, I'm going to show you something that we can do called U substitution, which is a method of solving something that is not quadratic in nature by modeling off a quadratic function. So that's a very useful tool. So let's begin by taking the square root. So quadratic equations are an equation where the highest power of a variable is 2. So we have x squared plus bx plus c. This is a quadratic equation in standard form. It's a polynomial, which means basically we don't have fraction powers, or we don't have negative powers. So, and the coefficients a, b, and c are real numbers. So this is a quadratic equation. Okay, so the first method is by taking the square root. I have on your worksheet the how and the what and the when. Okay, when do we use this? We use it, when do we use this method? We use it whenever it's easy to work our equation into the form a squared equals to b, where a is a function of x. So, or an expression, not function, let me just say an expression. An expression in x is what I'll say. An expression in x. It can just be x itself, or it can be something involving x. So, what is the method? The method is the how, is we get it into the form, the how. Get your equation, this equation, into the form something squared is equal to something. And then you take the square root of both sides. So, the next step is to take the square root of both sides of this, which looks like this. The square root is equal to plus or minus the square root. The square root of something squared is just the something. So a comes out. It's equal to plus or minus the square root of b. And so this is the how. Now, we'll just do a couple of examples. And so the first one that we have is to solve. Oh, by the way, throughout this worksheet, please read the instructions. The way I've worded this is asking you in many different ways that you will come across how to solve this equation. So sometimes I say solve for x, okay? Sometimes I say solve by using this method. Sometimes I say find the roots, find the x-intercepts, find the zeros, or just plain solve. Those are all mean the same things. We use the words roots, x-intercepts, zeros, and solutions interchangeably many times. And what we're solving for, when we set a quadratic equation equal to 0 and solve, we're going to get two answers, and those two answers are x-intercepts. We let y be 0 and solve for x, we're getting x-intercepts. That's what's happening. So, right here, let's do number 1, solve by taking the square root. So, when we do this, what they gave us is 4x squared minus 15 is 27. What we're supposed to do is get the something squared equal to something. In other words, isolate the something squared, which in this case is just x squared. Get this by itself. So let's add 15. And when you add 15, you get 42. And then we'll divide both sides by 4. So we get 42 over 4. Okay. Now we take the square root of both sides. You could also reduce this to 21 over 2. It's up to you. These are both correct. Let's just look at what might happen here. Let's take the square root of both sides. So when we do that, we take the square root of x squared is plus or minus the square root of this. The square root of x squared is plus or minus the square root of this. The square root of something squared is just an x, and so we get plus or minus the square root of 21 over 2. This is an acceptable answer to me. Many of you may be uncomfortable with not rationalizing your denominator, and if so, go ahead and rationalize it, and you'll end up with the answer that we get over here, I think. Here we go. here's our two answers. X is positive square root of 21 over 2. X is negative square root of 21 over 2. If I want to leave it in this form, this is plus or minus the square root of 42 over the square root of 4, right? Square root of 4 is 2, so this is plus or minus the square root of 42 over 2. So if you write it this way, you'll get X is square root of 42 over 2 or negative square root of 42 over 2. The plus or minus symbol is simply a convenient way of writing two separate answers. So I wanted to write these out separately at first just to make sure you see this is two completely separate answers. These are the same expression. We did not get four answers here. I'm just saying it's acceptable to write it this way to me, or it's acceptable to write it this way to me. These are we only got this is equal to this right here. And this is the same answer as this. What is the difference? I multiplied this by the square root of 2 over the square root of 2 in order to rationalize the denominator. You can get that right there. So we got two distinct answers. Later on, I might just leave the plus or minus squashed together, as long as you understand those are two separate answers. Okay, right here, let's solve number 2 says, find the roots by using the square root method. That means solve this equation for x, but we're going to use the method of taking the square root of both sides. So, it goes like this. If I have 3 times 4x plus 1 squared is equal to 30, by this method, what I want to do is isolate the something squared, or in other words, get this guy right here by himself. This is the something squared. Well, all I got to do in this case is divide both sides by 3. So if I do that, I will get 4x plus 1 squared is 10. And then I just need to take the square root of both sides. So the square root of this is plus or minus the square root of that. The square root of something squared is just the something. So what falls out of this right here is 4x plus 1 is equal to plus or minus the square root of 10. Then what I have to do is simply solve for x. So I subtract 1 from both sides first, and I get 4x is negative 1 plus or minus the square root of 10. And then I divide by 4. X is going to be negative 1 plus or minus the square root of 10 over 4. If I write these answers separately, I'll get x is negative 1 plus the square root of 10 over 4, negative 1 minus the square root of 10 over 4. Okay, so that is the method of taking the square root. Let's move on to method 2, which is the factoring method. So, I'm not going to go into a lot of detail about how to factor because we're in pre-calculus. However, if you find that you are not good at factoring and you need some help with that, let me know. Send me an email and I can send you some help with that, some worksheets and some videos to watch that explain in detail how to factor, because it's a skill you want to have for sure. So the next one, the instructions say we're going to look at the how and the when. Okay. So when do we use the method of factoring to solve a quadratic equation? Well, we use this when the equation is factorable with whole numbers. So when is when to use when the equation is factorable. So I said something funny, factorable with whole numbers. The truth is every single polynomial in existence is factorable, but can you factor it with nice numbers that are whole numbers like 2, 3, 4, negative 7, whatever? Instead of fractions and instead of square roots and instead of irrational expressions or imaginary numbers. So I mean whole number factoring. So that's what you guys are used to. How do we do this? Okay, how? Well, first you get a 0 on the right hand side. So you get your equation in this you get a 0 on the right hand side. Get a 0 on the right hand side of your equation. Number 2, then you factor the left hand side of the equation. And so what is factoring? It is rewriting something into multiplied form So we're taking something that's in it being added together and we're rewriting it into something times something. For instance, what are the factors of 21? Okay, here are two factors. We could rewrite 21 as 7 times 3. It's factored. We could rewrite 21 as 1 times 21. These are factors. This has been factored. Okay, that's all factoring means. So we're taking an expression that's being added or subtracted, and we're rewriting it into something times something, factored. Okay, so right here, we get a 0 on the right-hand side, we factor the left-hand side, and then we apply something called the zero product property. We apply the zero product property, which basically is this. It says if your product means multiply. So if you're multiplying some stuff together and it equals to 0, the only way that can happen is if one of the things you are multiplying is 0. So then we set each factor equal to 0. So what does number 3 mean by this? What we mean is set each factor equal to 0. And then solve for x. Okay, so I have 4 examples for this one because there's different ways you can factor, and I want to make sure that you are exposed to all of them. Number 1, the instructions say find the zeros by factoring. That means solve the quadratic equation by factoring. Number 2, use factoring to solve for the x-intercepts. Oh my goodness, x-intercepts, what does that mean? That means let y be 0 and solve for x. It's the same thing we're doing. 3, solve by factoring. 4, solve for the roots by factoring. Roots are the same thing as zeros, are the same things as solutions, are the same thing as x-intercepts. So solve the equation. So those are the words you might come across. Number 1, they gave us x squared minus 8x plus 12 is 0. Number 2, they gave us 3x squared plus 14x is negative 8. Number 3, they gave us 81x squared minus 64 is 0. Number 4, they gave us 7x plus 20, x squared is 0. Okay, let's do this. This needs to be factored. So I like the AC method, and what I mean by the AC method is A right here is 1, B is negative 8, C is 12. So we get a 0 on the right-hand side. It came to us that way. I multiply A times C, 1 times 12, and I try to find 2 factors of 12, 2 things I can multiply to get 12, but at the same time I can add up to get B. I can add up to get negative 8. And so I think about for a while and I realize that negative 6 times negative 2 would give me a positive 12, and negative 6 times negative plus negative 2 would give me negative 8. So these are the winning numbers. So when your leading coefficient is 1, when A is 1, this is all you have to do. You figure out these numbers and you rewrite this into factored form like this. It's going to be x minus 6 times x minus 2. You don't have to trust that ever. You can always check it. Multiply these back together and you should get this. And if you don't, then you don't have the right factorization. So what do? We got a 0 on the right-hand side. It came to us that way. We factored the left-hand side. Now we're ready to apply the zero product property, which said this factor, x minus 6 equal to 0, and this one, x minus 2 equal to 0, and solve for x. This will be true when x is 6 and x is 2. So here are my answers to this particular equation. Right here. Let's do this one. Get a 0 on the right-hand side. Oh, I need to add 8 to both sides. 3x squared plus 14x plus 8 is 0. I'm going to solve using the AC method. This time, A is not 1, it's 3, which means an extra step I got to do. So it goes like this. A times C is 24. What are 2 things I could multiply together to get 24, but I could add together to get B, which in this case is 14? Well, 12 times 2. 12 times 2 is 24. 12 plus 2 is 14. Now, since A is not 1, I can't just write x plus 12, x plus 2, because that is the wrong factorization. what I do this time is I split my 14x into 12x and 2x. 12x plus 2x. And the order that I wrote this down, like if I wrote down 2x plus 14x, it doesn't even matter. So copy down the first guy, 3x squared. I rewrite your middle term, either order, and then copy down the last guy, plus 8. Now, I've got a 4-term polynomial. What is nice to do, and what will always work with this method, if you get the right number, we got the numbers that work right here, group the first 2 terms together and the last 2 terms together, and then factor by grouping. What is the greatest common factor between 3x squared and 12x is a 3x. What is the greatest common factor between 2x and 8? A 2. Okay, what's going to happen? In the first set of, in the first grouping, if I factor out a 3x, I'm left with the x plus 4. If I factor out a 2, I'm left with an x plus 4. That's not coincidence that these are the same, that's factoring. Now we factor out the x plus 4, and we're left with 3x plus 2. This is factored. Set each factor equal to 0 and solve. X is negative 4, x is negative 2/3. That will be our 2 answers right here. These are x-intercepts. This is where it's going to cross the x-axis. Keep that in mind. That's what we're solving for. Okay, number 3. 81x squared minus 64 is 0. I have seen a student, it blew my mind. I didn't know it would work. She used the AC method for this, and it worked for that, which is great. So that's a pretty strong method that will always work. However, I think it's, I like to recognize that this is, just because this is the way I see it, that's why I like it, that this is difference of squares. This is something squared minus something squared. This is, see, what's the square root of 81x squared? This is 9x squared minus 8 squared. I recognize that this is difference of squares, and so difference of squares, a squared minus b squared factors into a plus b times a minus b, or vice versa. So this can factor into 9x plus 8 times 9x minus 8. And then we can set each factor equal to 0 and solve. 9x plus 8 is 0. X is going to be negative 8 over 9. 9x minus 8 is 0. X is going to be 8 over 9. These are our 2 answers right here. This guy, factor that guy. Lots of students think that you can't factor that guy, but you can. He doesn't really fall into the AC method or difference of squares or sum or difference of cubes, but it has a common factor, and if there's a common factor, you can pull it out. They both have an x. Factor out the x, leaving you with the x plus 20x. Set each factor equal to 0. X is 0 is one answer. 7 plus 20x is 0. So you'll get here x is negative 7 over 20. These are your 2 answers for that one. So that's the first 2 methods.